revenue or marketing expenditures the previous month, dollars, how much did I spend on marketing? What would the T+1 variable, what could it possibly be? T+1.
Marketing expenditure next month.
Well, yeah, it could be marketing expenditures next month. It could be number of customers 1 month after, number of individual customers. It could be anything over any time period that you think is related to the current time period. But in this case, right, we added the +1. So this is
The current time.
correct. If I made this, I took out that -1, what is that?
Linear.
That's just a standard linear regression. Cross-sectional, not time series.
Right.
It's what we've done all semester. The only thing that we're changing, in this case, is we're looking at what kind of variable is x1? Not what its name is, what type of variable is it?
IV.
Right, independent variable. So we're looking at independent variable at a different time period. And of course, we can do that in Stata, because in Stata, there's a command that you can say, this is my time variable. Whether it's weeks, you just point at a variable, and you tell Stata, this is my time variable. And Stata, when you put, for instance, t-1, it will look at that variable 1 month previous to whatever this variable is. And if this were t+1, it would look at a variable 1 time period plus the one that you happen to be evaluating. And that's it. It just goes in to 1 time period less and grabs whatever that data happens to be. So in time series data, all we're really doing is allowing Stata to look at the same data over different time periods. So for example, we have the 2010 GSS data set. That's what we use. We could combine the 2010, 2011, 2012.
As I'm sure they do.
Yeah, absolutely they do. We could combine those, and we define the year. The year would be 2010. There'd be a column, year. And I would tell Stata year is the time variable. And if this variable were in 2010 or 2011, this variable would be pulled from 2010, and this variable would be pulled from
I can't remember what that is.
t+1.
Oh, is it a +1?
Yep.
We changed it so many times.
Yeah, I did. It's supposed to be a +1. So what year would it be?
2011.
12.
12, right? So that's it. It would just go in and grab the data from that particular data set. It's that simple. And it would look for correlations. Okay? So that's a simple model.
So would that be, so the T, would it be year 10, year whatever, or would it be, like, would you annotate 2010? I mean.
Yes, you would tell Stata what the year variable is and what year t equals 0, and what year you want to be t equals -1 and t plus.
Okay.
So you have to tell Stata that, what the years are.
You can tell Stata so much. You would think Stata would be far smarter than that.
Yeah, no, it's not that smart. It'll do whatever you tell it, even if it's wrong.
I know.
For example, if you forget to expand a categorical variable with more than 2 categories, Stata will happily do it,
Oh, yeah.
right? It won't know, but the results will be crap.
Yeah.
So, all right,
Love it.
second model type. So this is a distributed lag model. And obviously non-simple. So y sub t equal to some alpha sub 0 plus beta 0 plus beta 1 x t minus 1 plus beta 2 x sub t minus 2 plus dot 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 beta sub rho x sub t minus rho plus, God, that's horrible, plus epsilon. So one of the ways we know that this is not a simple model is,
Well, it just looks like it's
it looks a whole lot more complicated, but we have this new constant called alpha sub 0.
It does not look like an A at all.
Yeah, no, it's not. It's It looks like a fish. That horizontal, if I would have drawn it horizontally, that's alpha. If you look in your book, it's a much better depiction. So we have this extra variable. These are all the same, right? T minus 1. However, notice that the time model is occurring over many potential time periods. T minus 2, T minus 3, T minus 4, and on to T minus n, some number. So this is a distributed time series model. Simple model, standard distributed time series model. And Stata handles both of those equally well. There's one additional model type that I want you to be able to understand. And let's talk about that.
Dynamic?
Yes. And dynamic's interesting because or recursive it's also called, because it'll stretch your mind a little bit.
Artwork involved in that.
Yep. So, y sub t equals some alpha 0 plus beta 0 x sub t plus... Does anybody know the name of that symbol?
Crane?
No. How about you, Brian? You want to take a guess? You remember?
I can't remember.
Lambda. Lambda y.
I knew it was an animal.
Lambda. No, not llama. Lambda.
Lamb.
T minus 1 plus
Duh.
u sub t. So, this is a simple dynamic model, and the reason it's dynamic is because it's recursive. Okay? Meaning, we have y sub t both as a dependent variable, y sub t, and then we have the same y sub t in the model, but except as a independent variable at a different time period. At a different time period. So it's treating a dependent variable as an independent variable as long as it belongs to a different time period. It's kind of hard to wrap your mind around. So let's look at...
I mean, it would have a different value then, right?
It does, exactly. This has to have a different value.
Make sure it wasn't perfectly whatever.
That's it. That was my next question. So it would be perfectly collinear if t and t here were the same.
Right.
You can't do that. Stata will blow up and say you can't have your dependent variable as an independent variable and a dependent variable. It doesn't work that way. They're perfectly multicollinear. So we have this as a different time period. Now, what sense does it make to treat a dependent variable both as a dependent variable and an independent variable? Why would we ever want to do that?
When you compare them at different time frames.
Exactly. So what you can say is, my current revenue, let's say that y sub t is current revenue. My current revenue is a function of my previous revenue, which is actually a pretty common assumption.
What does
Right.
lambda do?
What's that? So
That's just
lambda
telling you,
is just telling you this is a new independent variable related to, and we could put any symbol we want in here. We're just using another Greek character. There's nothing special about it. It's just not beta. So we're putting lambda in to show that this is not just a standard beta
I
coefficient.
think Gene Jane's trying to explain this to
Oh, do you want to explain it? Were you trying?
No.
Oh,
I just think this equation is very interesting because you did not teach us last semester.
that's right. I didn't teach you this last semester.
You
That's
teach
be-
more things this.
Yeah, we didn't get to this because we had a bigger class and more questions. So you guys are getting the one-on-one treatment.
Well, thank you.
So anyway, it turns out that you can look at, we call these, think of them as phase shifts. That one, the function of our dependent variable is a function of what that value was the last time period. And then we can treat that as a whole new variable, and we can look at the relationship between a dependent variable at time t equals 0 now as it's related to the previous time period. So it's treating the data in a previous time period as simply another independent variable. Right? We could do a correlation on those two. We could examine how monthly performance or annual performance year over year is related. So
Yeah, and how different, independent variables affect that same correlation.
yeah, exactly. If you look at this data and I were to interpret this, a 1 unit increase in income the previous year is correlated with a lambda increase in income this year. Let me say that again. A 1 unit increase in sales the previous year is associated with a lambda, whatever that value is, 1, 0.1, 0.8, whatever it is, increase in the current year. So I can forecast performance year over year. And I could look 1 year before, 2 years before, I could go on as far as I wanted to.
And project.
That's right. What's one place where it would be nice if we could do this, where we could make a lot of money? Stock market. If you
Well,
could, if you,
But that's so volatile sometimes. There's the consistency isn't there.
that's exactly right.
At
Exactly.
the same time, the consistency is there in the national debt. Go ahead and figure that number out.
Yep.
Just a lot of zeros.
What is it you hear all the time? Past performance is no indicator of future performance. And so this is trying to correlate past performance
Right.
with current or future performance. And it's hard to predict in the stock market. But if we could, I mean, this model makes sense, but as you indicated, why won't this work? And put it in terms of what you've learned this semester. This is the error term.
There's
Why won't
too many
this-
variables? There's an infinite number of variables.
Well done, my son. Very well done. Everything, this error term is so large that the R squared on this model will be so small, it will be worthless.
Right.
That's why. There are so many variables that impact a company's performance that you can't capture in a simple model. You'd have to build an incredibly complex model. And people do that. And
They get paid a whole lot of money to do that.
that's exactly right. And
Go to school that long.
And if they can make these recursive models work, and they can predict what a stock might do as a function of time, based on a whole bunch of variables, they can make serious money. And it turns out you can do that, right? So if I were wondering let's say that this variable was Intel's income, Intel's annual income. What could the drivers be of Intel's annual income? One might be the number of computers sold that year, right?
I know the guy that you're talking about right now. I mean,
What?
not literally. Like there's a guy I know that does that, and he builds those models.
Yep.
And he creates a. He's got this online thing that you put in what you're wanting to do,
Mm-hmm.
and it will throw a model out like that, and I don't whatever however many different equations or variables or whatever he put in the equation.
Right. So the whole idea here is if you can identify the major things that impact, in this case, Intel's revenue, if you could identify those, and if you could predict what they're going to be at time t+1 or t+2 or t+3, and you can build an accurate enough model, i.e. you've captured all of the independent variables that matter and left only the independent variables that don't matter in the error term, you could make serious buck by doing that. And there are a lot of trading firms that build models. These models, the number of variables are in the thousands, and they're dynamic. So it will go back and grab data from previous time periods, throw it in that model, and look for correlations.
Yeah.
And by the way, when they do this, they only have to make a few cents per second to make a ton of money over a very short period of time. So if they can predict a stock's movement, they can make a lot of money. But if their model isn't accurate, if the R squared is very low,
Can go the other way.
it could, that's exactly right. It goes the other way, and what happens? You lose a ton of money, right? Yeah, yeah. So that's really, with respect to lag models, this is how lots of companies on the stock market or brokerage firms evaluate stocks, by very, very complex recursive models.
Well, I'll tell you what. You have taught me that I have a very simple question to ask my stockbroker guy,
Mm-hmm.
and if he can't answer something along those lines,
I'm thinking he's not going to be able to answer that. Just ask him what lambda is and see what he says.
Who?
Yeah, exactly. You mean llama?
Sure, I've had that before.
So, in the event that we ever do an advanced quantitative class, and I'm thinking about it, I just have to wonder how many students will actually opt to take an advanced class. I think not many. We would go in and start talking about how to use time series models, so that you could build your own models if you wanted to. And we'd also talk about variables that are nonlinear. So if this variable, for instance, instead of being a ratio level variable, were a 1 or a 0, 1 or 0, how do we deal with that? And I think I showed you a probit model that I ran for the chancellor to predict which students would enroll after being dropped. So there's lots of techniques and lots of types of analysis that can be done with regression, not just the simple linear regression that we've done. So time series, probit, logit, just all these kind of interesting regression models that you just as soon forget, I'm sure.
I almost became one of your statistics. I got that email talking about something. We're gonna drop you for $46. I was like, y'all are stupid. I mean, $46.
Oh, you mean from UNCP?
Yeah.
Oh, because you hadn't paid something?
Yeah, whatever. I thought it was automatic.
Yeah.
But actually it was.
They didn't really threaten to drop you, did they?
Yeah, they sent me the email like, hey, you'll be dropped if you.
Oh, that's the nasty gram. They're saying.
Like $46? Come on, you can't just hold my transcript or something.
Yeah. No way, I'm kicking you out.
Yeah.
But it probably made you pay the $46, right?
Well, I thought of I'll let them go a couple weeks, but
Oh, yeah, make them suffer, not earn interest on that.
I want to see if you really do this because the money's.
Oh, don't do that, because that would create a paperwork nightmare for me.
Yeah.
Right. Oh, he's not showing up. I can't issue a grade. Oh, he'll show up the middle of next semester. Yeah, don't do that, please.
No, yeah.
Just graduate.
That's the plan. Been working on it for 10 years now. No, I'm just kidding.
Okay, yeah, 10 years. By the way, it took me 13 years to do my undergraduate, 13 years to do my electrical.
Oh, it took me 10 years for my associates.
Yeah, because I was working
Yeah.
full-time plus, just hacking out one class per semester, so I could relate.
This has been a 2-year stint, which is
Not bad.
I'm on.
And you've only got 2 classes left, or?
Well, we're gonna talk about that.
Okay, excellent. Well, we are wrapping, yeah, I saw the emails. So that's why I brought it up.
Yeah.
So any questions about anything we've learned about the final project? Anything? Because this is your last chance before you present your final project.
Monitor your email.
Yep. Well, I'll be doing that, and the discussion board.
And the bat phone.
Any questions? You feel like you're in good shape?
I think so.
Yeah. Based on your previous work, I'm betting you are probably.
I do have one question though.
Yes.
It's going back, I don't know if you remember when I was doing my research poster,
Uh-huh.
and we thought age should be, statistically significant. but
Yes,
it
that's
wasn't.
right, but it wasn't. Yep.
Well, I ran my regression just using my DV and age.
Yep.
And it was.
Okay.
So should I look for?
So here's what I would do. How statistically significant was it?
Not much. I think the t-value was like 2.2.
Oh, jeez. On a bivariate regression?
Yeah.
As soon as you add another 1 or 2 more variables, no matter what, exactly, it'll probably drop off.
Okay.
Which means that you haven't. It isn't a very strong relationship.
Okay.
So as soon as you add a different independent variable along with it, it sucks some of the statistical significance out of that age variable, and now age drops out of being stat sig.
And
So-
what was the significance of age being stat sig?
Yeah, what was your dependent variable?
Occupational prestige.
Oh, and you were thinking that age would.
Sure, yeah, the older, like for instance, you got a kindergartner. Okay, no, let's say you got an 18-year-old since
Yeah,
GSS is 18, and he's working at Taco Bell. What's his SEI?
Well, it's
It would be
well,
pretty low. But like you guys, let's say he goes to school, he gets his degree. Now he's not 18, he's 28, and he's got a master's degree. You would expect it to go up, right?
But that would make it significant, wouldn't it not?
It would. That's why I'm surprised it's not significant.
I thought
Yeah,
you
yeah,
said
no,
it was.
that's right. No, he's saying it was only significant in the bivariate model. As soon as he added another
My
a
full
second,
model, it's not.
right, in his full
Just
model,
on
it's
how
not.
big it was.
Did you expand it? Just for the hell of it?
You can't expand it. Oh no, you can't do that. Yeah, you know what that would do? 18 to 100, he'd have I_1. So you could do it, but boy, would it be ugly. Yeah, so don't do that.
No.
Yeah, that would be funny. Yeah, so I'm surprised that it's not. I would add a line when you talk about your model. Just say, I tested age and it wasn't stat sig.
So on the other thing, like, all right, so he's got a 2.02 on something. It's stat sig.
Mm-hmm.
Forgot something like 1.8. You know, I mean that's close to being stat sig too, right?
It is.
I wanted it to be stat sig. And
So some
just
journals
call it
will
sig.
publish 90%, so they'll consider a 90% confidence interval as being reportable.
Yeah.
Now in public administration, generally not. So, but others do.
Yeah.
So maybe you need to get a job in another sector, and
Well, can't I just like make stuff up?
You
know?
can.
And
and professors do that too. And when they get caught for doing that, they lose their PhD. But you didn't know that. They
can you
start-
lose
that? Yes.
title
Yes.
that you
They'll
paid for?
take or doctorate away. Yes.
Dang.
Yes. In fact, a
See, now
famous,
that-
famous
I find that hilarious because they give people doctorates for free.
yeah, but those honorary doctorates are not real doctorates. Those people can't claim to be a doctor. They can't be called doctor.
If you can be called a doctor because you can rap, you should be able to be called doctor because
okay. Yeah.
I know
guess
a doctor who would
Dr.
not-
Dre or something. I don't
Yeah,
know.
Dr. Pepper. But so, I know a guy who has a doctorate that I swear he bought offline somewhere, and he will not let people refer to him as anything other than doctor. And I'm like, dude, are you
Wow.
serious?
So as soon as my students graduate, I say, call me Joe. While you're my student, I prefer doctor.
Yeah.
But
Well,
as soon as
but
you
you
graduate,
earn
it's
you
Joe.
earn the title, you know, and not only that, but you can speak to it.
But I'm not stuck on it either, right? I
Yeah.
don't want my peers calling me doctor. I don't want my students after they graduate calling me doctor.
I mean, I understand a doctor, you know, being one. They should be called doctor. However, if you bought it or it was honorarily, you know,
Yeah, if it's honorary, you're not supposed to use it as a title. But if people do, you know, I think
I'm going to
Bill
use my
Cosby
3
was
letters when I get
given
that.
a doctorate, honorary doctorate. So,
Matter
yeah,
of
well,
fact-
you could just go buy one. Just go buy a doctorate. It's one of these online schools, University of Phoenix or something.
I'm going to make sure everybody calls me Frank McDaniel MPA.
There you go. Yeah, exactly.
I'm going to be like, that's MPA.
That's right. Not just Frank McDaniel. Frank McDaniel, comma, MPA.
Oh, and let me get my my certified fraud investigator
Oh, there you
certification.
go.
I'm going to be like, that's MPA CFE.
There you go. Yeah. I've actually seen emails from people that have this really huge, long set of acronyms after their name.
People love that. I don't know.
I guess so. All right. If there are no more questions, you guys are free to go, except for you, because we need to talk about
Yeah.
whatever issues going on in your world.
Oh, well, you got some time?
Yes, of course I have time. I have lots of time.
I assure you.
And video guy, you can cut the video now, because we don't want to broadcast.